immeasurable void of space, the universe is constantly in motion. It is a place of profound and unending transformation, a celestial ballroom where galaxies pirouette over eons. Stars are born in fiery cradles of dust and gas, and ancient suns meet their explosive ends. For most of human history, we have looked upon this cosmic ocean and perceived it as a place of serene, clockwork predictability, governed by the silent, unyielding force of gravity. We saw it as a grand, disconnected stage, where distant events were merely beautiful pictures in our telescopes, their stories too far away to ever touch our own. But a new understanding is dawning. It is a realization pieced together from the faint signals of distant phenomena and the energetic outbursts in our own cosmic backyard that the universe is far from disconnected. It is instead a vast, interwoven web of energy. It is a place of whispers and echoes, where the cataclysmic roar of a dying star hundreds of light years away can ripple through the fabric of space and elicit a response from our very own sun. This is the story of one such cascade, a remarkable chain of events that connects the deepest reaches of the galaxy to the inner workings of our solar system. It is a narrative that unfolds step by step, domino by domino, revealing a profound and startling interconnectedness. It is a story that begins with a prelude of unimaginable violence, a flash of high-energy light from the stellar graveyard. It continues with the unexpected reaction of a lonely traveler from the solar system's icy fringe. It climaxes with the furious, targeted response of our own star, and it builds towards a future date, a moment of celestial geometry so rare and precise that it promises to test our understanding of the very forces that govern our cosmic home. This is a journey into the heart of a living cosmos. We will move beyond the simple mechanics of orbits and gravity to explore the invisible yet all-powerful realm of electromagnetism and plasma. We will deconstruct a sequence of events so tightly correlated in time and space that they challenge the very notion of cosmic coincidence. We will bear witness to a celestial symphony, a story that reminds us that our solar system is not an isolated island, but a dynamic and responsive participant in the grand, energetic dance of the galaxy. Chapter 1: The Distant Overture, a Storm of Starlight. Our story does not begin with the familiar sun or the planets we know. It begins in an entirely different part of our galaxy, in a place of stellar death and violent rebirth. To understand the first link in this extraordinary chain, we must first understand the life and death of stars. The stellar life cycle and the white dwarf remnant. A star like our sun lives for billions of years in a state of delicate equilibrium. In its core, the crushing force of its own gravity is perfectly balanced by the outward pressure generated by nuclear fusion, the process of fusing hydrogen atoms into helium. This process releases a tremendous amount of energy, which we perceive as sunlight. But this fuel is not infinite. After about 10 billion years, a sun-like star exhausts the hydrogen in its core. The delicate balance is broken. The star's core begins to collapse under its own weight, causing temperatures to skyrocket. This new heat ignites a shell of hydrogen burning around the core, causing the star's outer layers to expand dramatically. The star swells into a red giant, hundreds of times its original size. Eventually, after further cycles of fusion and collapse, the star sheds its outer layers, creating a beautiful, glowing structure known as a planetary nebula. What remains at the center is the star's exposed core, a white dwarf. This is one of the most extreme objects in the universe. It is a sphere of matter so dense that a single teaspoon of it would weigh several tons on Earth. A white dwarf can contain the entire mass of our Sun, a star over 1,000,000 kilometers in diameter, crushed into a ball no larger than our own planet. It no longer produces energy through fusion. It is a stellar ember, slowly cooling over trillions of years. Its immense gravity is held back from further collapse, not by heat, but by a quantum mechanical principle known as electron degeneracy pressure. The electrons within the star are packed so tightly that they cannot be squeezed any closer, creating a rigid and stable structure.
The cosmic vampire, binary systems, and the nova mechanism. Many stars in the galaxy, unlike our solitary sun, are born in pairs, locked in a gravitational dance known as a binary system. If one of these stars evolves into a white dwarf, while its companion is still a main sequence star or a red giant, a dramatic situation can arise. The white dwarf, with its incredible density and powerful gravity, can become a cosmic vampire. As the companion star orbits, it can swell to a point where its outer atmosphere crosses a gravitational boundary known as the Roche lobe. Past this point, the white dwarf's gravity is stronger than the companion star's. The white dwarf begins to siphon material, mostly hydrogen gas, from its partner. This stolen gas does not fall directly onto the white dwarf. Instead, due to the conservation of angular momentum, it spirals inwards, forming a flattened, rotating structure called an accretion disk. This disk of superheated gas glows brightly as friction and gravitational forces heat it to millions of degrees. From the inner edge of this disk, a steady stream of hydrogen flows onto the surface of the white dwarf. Over thousands of years, this hydrogen accumulates, forming a thin, dense blanket on the star's surface. As the layer deepens, the pressure and temperature at its base build relentlessly. The white dwarf's own intense gravity compresses this layer, pushing it closer and closer to a critical threshold. When the temperature at the bottom of the hydrogen layer reaches approximately 10 million degrees Celsius, a tipping point is reached. A chain reaction of thermonuclear fusion ignites. But unlike the stable controlled fusion in a star's core, this is a thermonuclear runaway. In a matter of seconds, the entire surface of the white dwarf is engulfed in a cataclysmic explosion. This is a classical nova. The explosion is so powerful that it blasts the accumulated layer of hydrogen out into space at thousands of kilometers per second. The star's brightness increases by a factor of tens of thousands, sometimes even millions, in just a few days. To early astronomers, it looked as if a new star, Stella Nova, had suddenly appeared in the heavens. The high-energy aftermath, an invisible tsunami. The energy released in a nova is staggering, but much of it is invisible to the human eye. The explosion produces radiation across the entire electromagnetic spectrum. The shock waves and superheated plasma generate intense, high-frequency radiation in the form of X-rays and gamma rays. These are photons of light with incredibly short wavelengths and immense energy, far beyond visible light or even ultraviolet. Gamma rays are the most energetic form of light in the universe, typically produced by the most violent events, such as nuclear explosions and stellar cataclysms. X-rays, while less energetic than gamma rays, are still potent enough to penetrate matter and carry significant energetic information about their source. In the weeks preceding the main events of our story, two such novae erupted in our galactic neighborhood, V7994 Sagittarii and V1935 Centauri. Our space-based observatories, such as the Neil Gehrels Swift Observatory and the Fermi Gamma Ray Space Telescope, are designed to detect these high-energy flashes. They registered the brilliant X-ray and gamma-ray afterglows of these two novae. What this means is that a coherent, directed wave of high-frequency, highly energetic photons washed over our entire solar system. This was not a gentle lapping of cosmic waves. It was a tsunami of energy traveling at the speed of light. This wave of radiation, born from stellar fire, passed through interstellar space and saturated our local environment. It interacted with the sun's magnetic field, it showered the atmospheres of the planets, and it energized the tenuous gas and dust of the interplanetary medium. This cosmic energy bath is the first critical event in our chain. It did not cause anything directly, but it changed the ambient conditions. It primed the pump. It added a significant dose of external energy into the delicate, interconnected system of our solar system, setting the stage for a dramatic and visible reaction from one of its most sensitive inhabitants.
The next player to enter our cosmic stage is a visitor from the deepest, coldest recesses of our solar system. It is a relic from a time before the planets were fully formed, an object known as Comet C/2025 R2, SWAN. To grasp the significance of its behavior, we must first journey back in time to the birth of the Sun and planets. Pristine relics, the Oort cloud, and the nature of comets. About 4.6 billion years ago, our solar system formed from a vast rotating cloud of gas and dust called the solar nebula. At the center, gravity pulled most of the material together to form the Sun. In the warmer, inner regions of the surrounding disk, rocky planets like Earth and Mars formed. In the colder outer regions, beyond the frost line, abundant water ice allowed giant planets like Jupiter and Saturn to grow. The material left over from this process, trillions of small icy bodies, was scattered by the gravity of the giant planets. Some were flung into a distant spherical halo surrounding the entire solar system, a theoretical region we now call the Oort cloud. This vast reservoir of comets extends perhaps a quarter of the way to the next nearest star. Here, in the near absolute zero of interstellar space, these dirty snowballs have remained in a pristine, frozen state for billions of years, perfect time capsules of the early solar system's chemical makeup. These icy bodies are composed of a mixture of water ice, frozen gases like carbon dioxide, carbon monoxide, methane, and ammonia, all interspersed with rock and dust. Occasionally, the faint gravitational tug of a passing star or the tidal forces of the Milky Way galaxy itself can disturb the orbit of one of these Oort cloud objects, sending it on a long, slow journey towards the inner solar system.
The anatomy of a comet, coma, and tails. For thousands of years, the comet travels inwards. As it crosses the orbit of Neptune, it is still just a dark, frozen nucleus, perhaps a few kilometers across. But as it approaches the Sun, its transformation begins. The increasing solar radiation heats the nucleus's surface. In the vacuum of space, the frozen gases do not melt into liquid. They undergo sublimation, turning directly from solid to gas. This outgassing process releases a torrent of gas and dust from the nucleus, forming a vast glowing atmosphere around it called the coma. A comet's coma can grow to be larger than the planet Jupiter. Sunlight further breaks down molecules in the coma. For example, water is broken into hydrogen and oxygen. This creates an enormous invisible envelope of hydrogen around the comet, which can be millions of kilometers in diameter. As the comet races closer to the Sun, it is subjected to two powerful forces. The first is solar radiation pressure, the physical push exerted by photons of sunlight. The second is the solar wind, a constant stream of charged particles, protons and electrons, flowing from the Sun at supersonic speeds. These forces push the material of the coma away from the nucleus, forming the comet's two magnificent tails. The dust tail is the more visually prominent of the two. It is composed of tiny, solid dust particles that are pushed away by the gentle pressure of sunlight. Because the dust particles are relatively heavy and move slowly, the tail curves gracefully along the comet's orbital path. It shines by reflecting sunlight and is typically yellowish-white in color. The ion, or gas tail, is composed of ionized gas from the coma. These lightweight charged particles are caught up by the magnetic field embedded in the solar wind and are flung straight away from the Sun, regardless of the comet's direction of travel. This tail glows through fluorescence as the ions absorb and re-emit solar radiation, often appearing a ghostly blue.
The outburst, a sudden eruption of light. Comet C 2025 R2 Swan was discovered, as its name suggests, by the Solar Wind Anisotropies instrument on the SOHO, Solar and Heliospheric Observatory. This instrument continuously scans the entire sky in a specific wavelength of ultraviolet light emitted by hydrogen, making it exceptionally effective at finding new comets as their vast hydrogen envelopes begin to glow. This particular comet had followed a predictable path. It reached perihelion, its closest point to the Sun, on September 12th and began its journey away from the star. Its brightness was tracked by astronomers worldwide using a scale known as apparent magnitude. This scale is logarithmic and inverted. A smaller number signifies a brighter object. A jump of one magnitude, example from 7 to 6, corresponds to an increase in brightness of about 2.512 times. For weeks, the light curve of Comet Swan, a graph of its brightness over time, followed the expected trajectory. It was predicted to be around magnitude 6.5, a faint object visible only with binoculars under dark skies. Then, on September 26th, the comet did something spectacular. It underwent a sudden, dramatic outburst. Its brightness surged. Observations confirmed it had jumped from its expected 6.5 to a brilliant 5.7. This change of 0.8 magnitudes might sound small, but due to the logarithmic scale, it represents a sudden increase in luminosity of more than double, 2.512 raised to the 0.8 is approximately 2.1. The comet, overnight, became twice as bright as it was supposed to be. This was not a gradual brightening, it was an explosive event. The cause of such outbursts is still an area of active research, but several mechanisms are proposed. It could be a thermal stress fracture, where a large fissure suddenly opens on the nucleus, exposing a vast new area of fresh, volatile ice to sunlight. It could be the phase transition of amorphous ice, an organized, glassy form of ice trapped in the nucleus since its formation, which releases a large amount of gas when it crystallizes. Or it could be the explosive release of a pressurized pocket of gas from beneath the comet's surface crust. Regardless of the precise mechanism, the timing is extraordinary. On September 26th, just days after the entire solar system was permeated by a wave of high-energy radiation from two novae, Comet Swan erupted. It is a compelling possibility that this external energy input provided the final push, the energetic nudge that triggered this instability on the comet's fragile nucleus. The second domino had fallen. The cosmic energy wave had arrived, and now an object within our own solar system had visibly, violently reacted. The comet was now glowing with an anomalous light, a beacon of its energized state. This powerful signal, it seems, did not go unnoticed by the most powerful object in the solar system. Chapter 3: The Sun's Furious Reply, a Targeted Solar Flare. The central character in our solar system's drama is and always will be our Sun. It is a star of immense power and complexity, a seething ball of plasma governed by magnetic forces of a scale that dwarfs human comprehension. To understand its role in this cosmic cascade, we must look deep into its turbulent heart and its fiery atmosphere. The solar engine, magnetism, and the 11-year cycle. The Sun is not a solid body. It is a sphere of plasma that rotates differentially. Its equator spins faster, about 25 days, than its poles, about 35 days. This differential rotation, combined with the convection currents of plasma rising and falling within the Sun's interior, creates a process called the solar dynamo. This dynamo generates the Sun's incredibly powerful and complex magnetic field.
As the cycle progresses towards solar maximum, differential rotation twists and tangles the magnetic field lines. This tangled magnetic energy bursts through the Sun's visible surface, the photosphere, creating dark, complex regions known as sunspots. Sunspots appear dark because they are slightly cooler than their surroundings. They are areas where the magnetic field is thousands of times stronger than Earth's, so intense that it inhibits the normal flow of hot plasma from the Sun's interior, creating a cooler patch. These sunspot regions, especially those with complex, tangled magnetic geometries, are the breeding grounds for the most violent events in the solar system: solar flares. Magnetic reconnection and the anatomy of a flare. Imagine the magnetic field lines above a complex sunspot group as a nest of giant, twisted elastic bands. As the sun's plasma churns and flows, these bands are stretched, twisted, and forced against each other. When oppositely directed field lines are pushed together, they can suddenly reconnect into a new, simpler, lower-energy configuration. This process of magnetic reconnection is fantastically explosive. The magnetic energy that was stored in the twisted field lines is instantaneously converted into other forms: the kinetic energy of accelerated particles and intense electromagnetic radiation. This is a solar flare. Flares release a torrent of radiation across the entire spectrum, from radio waves to gamma rays. For classification, scientists monitor the flux of X-rays, as this is the most direct measure of a flare's power. The classification scale is logarithmic. C-class flares are minor. M-class flares are moderate, with M standing for medium. An M-class flare is 10 times more powerful than the strongest C-class flare. They can cause brief radio blackouts on Earth. X-class flares are the most powerful, with X standing for extreme. An X-class flare is 10 times more powerful than the strongest M-class flare. They can cause widespread radio blackouts and long-lasting radiation storms. We are currently in solar cycle 25, and activity has been steadily increasing towards the predicted maximum. However, for several months leading up to late September 2025, the Sun had entered a period of relative calm. While there were many sunspots, they were not producing significant flares. The M6.4 flare, an unambiguous response. On September 28th, less than 48 hours after Comet Swan's dramatic outburst, this quiet period came to an abrupt end. At 8:30 Universal Time, a sunspot group designated Active Region 4232 unleashed a powerful eruption. Satellites monitoring the Sun's X-ray output registered it as an M6.4 class solar flare. This was a significant event. It was the most powerful solar flare observed in over 3 months, a clear signal that a major change in solar activity was underway. But the true significance of this flare lies not in its timing or its strength, but in its location. When viewed from Earth, the position of Comet Swan in space defined a specific line of sight, a particular directional vector relative to the Sun. The M6.4 flare did not erupt from a random location. It did not come from the center of the solar disk facing Earth, nor from the edge, nor from the far side. It erupted from the active region that was, at that moment, located at almost the exact same angular position on the Sun as the energized comet. The chain of events is now undeniable. A wave of high-energy nova radiation arrives. Comet Swan, at a specific solar longitude, responds with a massive outburst. Less than 2 days later, the Sun unleashes its strongest flare in months from that same solar longitude. This correlation strongly suggests a physical connection. The idea that a comet can influence the Sun is a frontier concept in heliophysics. One proposed mechanism is a direct magnetic connection. A comet with a large ionized coma can drape the Sun's own interplanetary magnetic field lines around itself. If these field lines connect back to an active region on the Sun's surface, the comet's outburst could have sent a disturbance, An Alfvén wave, perhaps, traveling along these magnetic field lines back to the Sun, providing the final trigger needed to destabilize the active region and unleash the flare.
The third domino had not just fallen, it had been slammed down with furious force. The Sun had answered the comet's signal, but its response was more than just a flash of light. The flare was the herald of something far larger, a physical entity now hurtling through the void on a direct collision course. Chapter 4: The Solar Hurricane, a Colossal Ejection. The M6.4 solar flare was the brilliant flash, the thunderous sound of a cosmic cannon firing. But every cannon fires a projectile. In this case, the projectile was a billion-ton cloud of magnetized plasma, a solar hurricane known as a coronal mass ejection, or CME. Flare versus CME, a critical distinction. It is crucial to distinguish between a solar flare and a CME, though they are often born from the same event. A solar flare is an eruption of energy. It is a flash of electromagnetic radiation, light, X-rays, gamma rays, that travels at the speed of light, reaching Earth in just over 8 minutes. Its primary effects are on our ionosphere and radio communications. A coronal mass ejection, CME, is an eruption of matter. It is a tangible cloud of plasma and embedded magnetic field ejected from the Sun's outer atmosphere, the corona. CMEs are much slower, traveling at speeds from a few hundred to over 2,000 kilometers per second. They take 1 to 4 days to cross the 150 million kilometers to Earth. A CME's impact is on planetary magnetospheres, capable of causing powerful geomagnetic storms. Not all flares produce CMEs, and not all CMEs are associated with strong flares. However, the most powerful eruptive events, like the M6.4 flare, often involve both. The magnetic recombination that powers the flare also destabilizes the overlying magnetic field, allowing it to blow outwards, expelling the coronal plasma that was trapped within it. Observing the invisible. The coronagraph. Detecting a CME as it travels through the blackness of space is a challenge. The Sun's own light is so blindingly bright that it completely overwhelms the faint light reflected by the tenuous CME cloud. To see them, scientists use a clever instrument called a coronagraph. A coronagraph, like the Large Angle and Spectrometric Coronagraph, LASCO, aboard the SOHO spacecraft, creates an artificial solar eclipse. It uses a solid occulting disk to physically block the direct light from the Sun's photosphere. This allows the instrument's sensitive camera to capture the much fainter light of the surrounding corona, and most importantly, to see any massive clouds of plasma that are ejected from it. In the hours following the M6.4 flare, the data from LASCO came down to Earth. The imagery was unambiguous. A large, fast-moving, and complex coronal mass ejection was seen billowing away from the Sun. The timing and the source location on the solar limb matched the flare perfectly. This was the physical bullet fired by the solar explosion. A calculated trajectory. The appearance of a CME in a coronagraph tells us a great deal about its trajectory. When a CME is directed towards Earth, it appears to expand outwards from the Sun in all directions, like a halo or a ring of light surrounding the occulting disk. This is a full halo CME, and it is a clear warning of a potential geomagnetic storm at Earth. When a CME is directed away from Earth, off the side of the Sun, its structure is seen in profile. We can observe its billowing loops and complex internal structure as it moves across the field of view. The CME launched by the M6.4 flare was definitively a side-profile event. It erupted clearly from the northeastern quadrant of the Sun and traveled outwards in that direction. It was not a halo CME. This solar hurricane was not going to hit Earth.
Its trajectory was precisely along the vector we have been tracking throughout this story. It was traveling along the Sun-Comet line. The Sun had launched a billion-ton wave of magnetized plasma into space, and it was on a direct intercept course with the very object that may have triggered its eruption, Comet C/2025 R2/Swan. The stage was now set for a titanic collision in the void. A fragile, ancient body of ice and dust, already in an agitated state, was about to be engulfed by a wave of superheated solar material, moving at over 1,000,000 miles per hour. The question now was, what would happen when the storm made landfall? Chapter 5. Collision in the Cosmos. A comet in the crosshairs. The impending encounter between the coronal mass ejection and Comet Swan represents a spectacular, large-scale plasma physics experiment. To comprehend the potential consequences, we must first understand the intricate, electrified environment that a comet creates around itself as it travels through the solar wind. The comet's plasma domain, an induced magnetosphere. A comet is far more than a simple chunk of ice. The gas that sublimates from its nucleus is quickly ionized by the Sun's ultraviolet radiation, creating a plasma, the fourth state of matter, a soup of positively charged ions and negatively charged electrons. This cometary plasma interacts directly with the ever-present solar wind, which is itself a magnetized plasma. Unlike Earth, which has a global magnetic field generated by its molten iron core, a comet has no intrinsic magnetic field. However, as the magnetic field embedded in the solar wind flows toward the comet, it encounters the dense, electrically conductive cometary plasma. This interaction causes the solar wind's magnetic field lines to slow down, pile up, and drape around the comet's coma, creating a structure known as an induced magnetosphere. This process creates a distinct boundary called a bow shock, where the supersonic solar wind abruptly slows down. Inside this boundary is a chaotic region of magnetic fields and plasma, and at its heart is the comet's coma and nucleus. This induced magnetosphere deflects the bulk of the solar wind around the comet, carving out a cavity in space, much like a rock in a flowing stream. The draped magnetic field lines are then drawn out behind the comet, forming the long, straight skeleton of the ion tail. When the hurricane hits, potential outcomes. This delicate, self-created plasma environment is maintained in a tenuous balance with the normal solar wind. A coronal mass ejection, however, is anything but normal. It is a tsunami compared to the normal ocean swell. A CME is denser, faster, and contains much stronger and more tangled magnetic fields than the ambient solar wind. When this solar hurricane strikes the comet's induced magnetosphere, the results can be violent and visually stunning. 1. Tail disconnection event. This is one of the most dramatic and frequently observed interactions. The magnetic field within the CME has its own orientation. If this orientation is opposite to that of the draped magnetic field in the comet's ion tail, a process of magnetic reconnection can occur.
The CME's field and the comet's tail field can explosively link up, severing the entire existing ion tail from the comet's head. The old tail then disconnects and floats away in the solar wind, while the comet immediately begins to form a new one. To observers on Earth, it looks as though the comet's tail has been completely ripped off. 2. Auroral brightening of the coma. The CME is laden with high-energy charged particles. As this dense wave of particles washes over the comet, it will collide with the neutral gas molecules in the coma. These collisions excite the gas molecules, kicking their electrons into higher energy states. When the electrons fall back to their normal states, they release photons of light, causing the entire coma to glow much more brightly. It is the exact same physical process that creates the aurora borealis and australis in Earth's polar regions, but on a cometary scale. Given that Comet Swan is already in a heightened state of activity from its outburst, this additional energy input could cause a second, even more brilliant surge in its luminosity.
3. Violent tail ripples and instabilities. A CME is not a smooth, uniform cloud. It is a turbulent, roiling mass of plasma with complex internal structures. As these structures sweep past the comet, they can send powerful magnetohydrodynamic waves, known as Alphen waves, rippling down the length of the ion tail. This can cause the tail to develop kinks, helices, and other dramatic formations, making it appear to flap violently in the solar gale. 4. Nucleus fragmentation. In the most extreme cases, the encounter could threaten the structural integrity of the comet's nucleus itself. The rapid changes in temperature from being engulfed in the hot plasma, combined with the immense pressure exerted by the CME's passage, could create significant thermal and mechanical stresses. If the nucleus is already fragile or has pre-existing fractures, these stresses could be enough to cause it to break apart, a process known as fragmentation. This would lead to a massive but terminal brightening event as the comet disintegrates into a cloud of smaller pieces. Given the size of Comet SWAN's already impressive tail, stretching over 2.5 degrees of the sky, 5 times the apparent width of the full moon, it presents a massive target for this interaction. It possesses a huge reservoir of gas and dust, promising a spectacular show. The collision is imminent. The next few days of observation will reveal the fate of this energized traveler as it endures the full fury of the sun's targeted blast. This event is the next crucial data point in our story, but it also serves as a dress rehearsal for an even grander convergence, one that involves another, far more enigmatic visitor. Chapter 6. The Enigma from the Stars. Interstellar Object 3I Atlas. The drama unfolding in our inner solar system involves more than just our own sun and its family of comets. In a remarkable stroke of cosmic timing, another, even more extraordinary visitor is present, a traveler from the gulf between the stars. To appreciate the full scope of the events building towards late October, we must turn our attention to this enigmatic object, 3I Atlas, the third confirmed interstellar object to grace our solar system. Messengers from distant suns, the reality of interstellar objects. For centuries, the idea of visitors from other star systems was purely the realm of speculation. It was assumed that the vast distances between stars made such journeys impossibly rare. But in 2017, that speculation became reality. A new generation of powerful survey telescopes, designed to scan the entire sky every few nights, finally became sensitive enough to spot these faint, fast-moving objects. The first was 1I Oumuamua. Its name is Hawaiian for a messenger from afar arriving first. It was a watershed moment in astronomy. Oumuamua was unlike anything seen before. It was small, no more than a few hundred meters long, and had a highly elongated, cigar-like shape. It was dark red in color, suggesting a surface rich in organic molecules that had been cooked by cosmic rays over millions of years of interstellar travel. Most bizarrely, it showed no visible signs of outgassing, no coma, no tail, yet it was accelerating away from the sun as if pushed by an unseen force, a phenomenon known as non-gravitational acceleration. The mystery of Oumuamua continues to fuel scientific debate to this day.
3I Atlas, an object of an unprecedented scale. The third confirmed interstellar visitor, 3I Atlas, is in a class all its own. While it has been classified as a comet due to its activity, the sheer scale of that activity is staggering and dwarfs that of any comet from our own solar system. The most astonishing feature of 3I Atlas is the size of its coma. Observations from ground-based and space telescopes have revealed that its gaseous atmosphere has expanded to a colossal diameter. At its largest, the coma of 3I Atlas was measured to be over 720,000 kilometers across, more than half the diameter of our Sun itself. It is a truly gigantic structure, a diffuse but immense cloud of gas and dust being shed by a nucleus that is likely much larger and more volatile than typical comets. This object entered our solar system on a hyperbolic trajectory, a path that proves it is not gravitationally bound to our Sun, and is merely passing through on its eons-long journey through the Milky Way. Its massive coma suggests it is incredibly rich in volatile ices that are sublimating at a prodigious rate, even at great distances from the Sun. It is a hyperactive interstellar comet. Like Comet Swan, 3I Atlas is a key player in the current celestial drama, and it too has been directly energized by the Sun. On September 25th, just one day before Comet Swan's outburst, a separate coronal mass ejection originating from a different active region on the Sun swept over 3I Atlas on the far side of the solar system. So within a 24-hour period, we had two major comets in our inner solar system, one of local origin and one interstellar, both being impacted and energized by solar storms. The presence of this gigantic, highly active, and recently energized interstellar object adds a profound layer of complexity and energetic potential to the mix. It is a powerful wildcard, a second major source of plasma and magnetic disturbance in the inner solar system. And it is the precise positioning of this interstellar enigma, in perfect concert with Comet Swan, the Earth, the Moon, and the Sun, that transforms the upcoming date of October 21st from a simple astronomical curiosity into a moment of unparalleled celestial significance. Chapter 7. The Cosmic Blueprint, the October 21st Alignment. As we approach the third week of October 2025, a series of seemingly independent celestial motions will converge on a single day, locking into a geometric alignment of breathtaking precision and rarity. This is not a vague or interpretive pattern. It is a physical, orbital reality, a cosmic blueprint laid out by the laws of celestial mechanics. Let us deconstruct the extraordinary celestial stage that will be set on October 21st. Pillar 1. The superior conjunction of 3I Atlas. On October 21st, the interstellar object 3I Atlas will reach a specific point in its orbit known as superior conjunction. This is a precise astronomical term. For an object with an orbit outside of Earth's,
It means that it will be located on the exact opposite side of the Sun from us. The three bodies will form a near-perfect straight line in space, in the order Earth, Sun, 3I Atlas. This alignment places the massive plasma cloud of 3I Atlas directly within the Sun's extended magnetic field as seen from Earth. Any magnetic field lines connecting the Sun and Earth, the Parker spiral of the solar wind, will extend outwards to pass directly through or near this gigantic electrically active object. It is the point of maximum potential magnetic and electrical connection between the Earth-Sun system and this interstellar visitor. Pillar 2. The new moon and a four-body syzygy. Coinciding with this superior conjunction, October 21st is also the date of the new moon. This occurs when the moon, in its 29.5-day orbit around the Earth, passes between the Earth and the Sun. At this time, the sunlit side of the moon is facing away from us, so it is invisible in our sky. The addition of the new moon to the alignment is significant. It completes a remarkable four-body lineup, a celestial configuration known as syzygy. On this day, four major celestial bodies will be aligned in a single, straight line across hundreds of millions of kilometers of space. 3I Atlas, Sun, Moon, Earth. Such a precise multi-body alignment is a testament to the elegant, predictable dance of the solar system, but its rarity makes it a moment of special interest.
Pillar 3. The perigee of Comet SWAN. As if this grand alignment were not enough, the third crucial event occurs on this very same day. Comet C/2025 R2 SWAN, the comet whose outburst kicked off this entire solar response, will make its perigee, its closest approach to planet Earth. On October 21st, Comet SWAN will be a mere 0.25 astronomical units from us. An AU is the average Earth-Sun distance, approximately 150 million kilometers. This means the comet will be less than 38 million kilometers away. In the vastness of the solar system, this is a very close pass. At this moment, the comet's physical presence, its gravitational influence, its magnetic field, and the density of the gas and dust in its coma and tail that Earth will pass through, will be at its absolute maximum. Earth will be more deeply immersed in the physical and electromagnetic environment of this comet than at any other time. The final piece. The significance of the ecliptic plane. The profound nature of this alignment is cemented by one final crucial detail that applies to both Comet SWAN and 3I Atlas, their orbital inclination. Most planets in our solar system orbit the Sun on a flat, disc-like plane, as if they were marbles rolling on the same giant plate. This is called the ecliptic plane. This plane is the action zone of the inner solar system. The Sun's equatorial current sheet, a massive, wavy sheet of electrical current, is aligned with the ecliptic plane. The solar wind is densest and most powerful along this plane. The Sun's magnetic field lines are most concentrated here. It is the superhighway of electromagnetic energy and particle flow. Most comets, especially long-period comets from the Oort cloud, arrive on highly inclined orbits. They dive down towards the Sun from high above the ecliptic, or rise up from far below it, cutting through this active plane at a steep angle. They pass through the zone of maximum interaction quickly and are then gone.
What is so extraordinary is that both Comet Swan and the interstellar object 3I Atlas are traveling on orbits with very low inclinations. Their paths are nearly parallel to the ecliptic plane. They are not just dipping in and out of the action zone, they are spending their entire passage through the inner solar system traveling within it, fully immersed in this dense, electromagnetically active environment. On October 21, this all comes together. We will have a perfect four-body alignment. We will have a highly energized comet making its closest physical approach to Earth. And all of these events will be taking place directly within the most electromagnetically potent region of our solar system. This configuration establishes the conditions for a powerful large-scale electrodynamic circuit to be formed, connecting the Sun, the Earth, and these two massive, highly active cometary bodies. Is such a connection plausible? Is there any historical evidence that such celestial configurations can have a tangible effect on our Sun and our planet? The answer lies in looking back to the last time a visitor from the stars passed so close. Chapter 8. Echoes from the Past. The Oumuamua Precedent. To assess the potential significance of the October 21st alignment, we are not without a guide. The universe often provides clues in the form of patterns and repetitions. In this case, we have a startlingly clear historical precedent: the passage of the first interstellar object 1I Oumuamua in the autumn of 2017. The events surrounding its closest approach to the Sun provide a chillingly precise parallel to the situation developing now, suggesting that the connection between these celestial visitors and solar-terrestrial activity is not a new phenomenon.
The context: a weak and waning solar cycle. In September of 2017, our Sun was in the declining phase of solar cycle 24. This had been one of the weakest solar cycles in over a century. Solar activity was low and had been steadily decreasing for years as the Sun drifted towards a deep solar minimum. The expectation among solar physicists was for continued quiet. There were some sunspot regions on the disk, but they were not predicted to produce any significant activity. It was, by all accounts, a sleepy period for our star. Into this quiet solar system came Oumuamua. Traveling at an incredible interstellar velocity, it looped tightly around the Sun, reaching its perihelion, its point of closest approach, on September 9, 2017. At this moment, the mysterious cigar-shaped object from another star system passed deep within the Sun's fiery corona, closer to the Sun than the orbit of Mercury. The solar response: the flares of the decade. On the very day of Oumuamua's perihelion, the Sun unleashed two of the most powerful solar flares of the entire decade. The X-ray flux chart from that week tells the story with stark clarity. First, an X2.2 class flare erupted. This was in itself a major event, the strongest flare in years, but it was merely the precursor. A few hours later, the same active region, AR2673, exploded with a colossal X9.3 class solar flare. An X9.3 flare is a monster event. It is near the very top of the solar flare scale. This single eruption was so powerful that it remains the strongest solar flare of the entire 11-year solar cycle 24. These were not just the strongest flares of the year, they were the defining eruptive events of the cycle, and they occurred on the exact same day that an object from another star system made its closest approach to our star. The probability of the two strongest flares of a weak declining solar cycle occurring by chance on the same day as the perihelion of the first interstellar object ever detected is infinitesimally small. It is a correlation of such stunning precision that it demands a physical explanation. The most logical conclusion is that the passage of the dense, fast-moving Oumuamua through the Sun's corona acted as a powerful trigger. It created a profound magnetic or electrical disturbance that cascaded through the coronal structures, destabilizing the active region and causing it to unleash its stored energy in a catastrophic fashion. The terrestrial connection, the strongest earthquake of the year. The echoes of this event were not confined to the Sun. They were felt here, on our own planet. In the 24 hours leading up to Oumuamua's perihelion and the historic solar flares, the Earth itself experienced a tremendous convulsion. On the evening of September 8, 2017, a massive earthquake struck off the coast of Chiapas, Mexico. It registered a magnitude of 8.2. This was the most powerful earthquake to be recorded anywhere on the planet in the entire year of 2017. It was a devastating event, triggering tsunamis and causing widespread destruction. Let us assemble this timeline with precision. September 8th, the strongest earthquake of the year occurs on Earth. September 9th, interstellar object Oumuamua reaches perihelion, its closest approach to the Sun. September 9th, the Sun responds with the two most powerful solar flares of the entire solar cycle. This temporal clustering of the year's most extreme seismic event, with the decade's most extreme solar events, all centered on the arrival of an interstellar visitor, is a pattern that is difficult to ignore. It suggests a deeply interconnected system where energetic shifts in the solar environment, perhaps triggered by an external object, can have a tangible and immediate effect on the geophysical systems of our own planet. The precise mechanisms for this Sun-Earth connection are still debated, whether it's through electromagnetic induction, changes in atmospheric pressure, or the influx of high-energy particles, but the correlation in this case is undeniable. The Oumuamua precedent provides a powerful lens through which to view the events of 2025. We are once again seeing a celestial visitor, in this case, two highly active objects, whose presence is correlated with a significant uptick in solar activity. It is all building towards a grand alignment that is, by several measures, even more complex and involves a much closer approach to Earth than the 2017 event. The past echoes into the present, serving as a stark reminder that the arrival of these messengers from afar are not passive spectacles. They are active participants in the life of our solar system, capable of triggering profound and powerful responses. Chapter 9: A New Paradigm: The Electric Solar System. The remarkable sequence of events we have chronicled, from the distant novae to the impending grand alignment, challenges the very foundation of our classical gravity-dominated view of the cosmos. While gravity masterfully explains the orbits of planets and the structure of galaxies, it cannot account for the sudden, energetic, and seemingly connected phenomena we are witnessing. To find a more complete explanation, we must embrace a new paradigm, one that acknowledges the profound and often overlooked role of the universe's other fundamental force, electromagnetism. Beyond gravity, a universe of plasma. The standard model of the solar system often treats interplanetary space as a perfect, empty vacuum. This is a profound misconception.
We now know that 99.9% of the visible matter in the universe is not solid, liquid, or gas, but is in the fourth state of matter, plasma. A plasma is a gas that has been heated to such high temperatures that its atoms have been stripped of their electrons, creating a sea of free-floating charged particles, ions and electrons. Plasma is an excellent conductor of electricity and is intensely responsive to magnetic fields. Our entire solar system is filled with plasma. The sun itself is a ball of plasma. The solar wind is a stream of plasma. A comet's coma and tail are clouds of plasma. The Earth's magnetosphere is a bubble of plasma. From this perspective, our solar system is not a collection of inert bodies in a void. It is a dynamic, interconnected system of plasma structures, all interacting through the forces of electromagnetism. The sun as a power source, space as a circuit. In this electric universe model, the sun is not just a gravitational anchor, it is the central power source of a vast electrical circuit. The sun's rotation and its powerful magnetic field act as a giant homopolar generator, inducing a voltage difference of billions of volts between its poles and its equator. This voltage drives a constant outflow of electrical current carried by the solar wind. This current flows outwards along the sun's spiraling interplanetary magnetic field. The planets with their own magnetic fields and ionospheres are like components, resistors, capacitors, and inductors embedded within this solar circuit. The circuit is closed by currents flowing back towards the sun along the vast heliospheric current sheet and through the polar regions of the heliosphere. Comets as active circuit elements. In this electric paradigm, comets are not merely passive, melting snowballs. They are dynamic, electrically active bodies. As a comet approaches the sun, it travels through regions of varying electric potential and plasma density. The comet's highly conductive plasma coma can create a significant electrical discharge between itself and the surrounding solar wind plasma. This is analogous to how a capacitor works. The comet's nucleus and dense inner coma can accumulate electric charge relative to the surrounding space. When the voltage difference becomes too great for the intervening plasma to insulate, a discharge occurs. A cometary outburst in this view can be seen not just as a mechanical failure of the nucleus, but as an electrical breakdown event, a giant spark or arc discharge that releases a burst of light and matter.
Let us now re-examine the entire chain of events through this electrical lens. An external power surge. The high-energy X-rays and gamma rays from the novae do not just pass through the solar system, they charge it. This wave of ionizing radiation adds energy to the entire system, increasing the overall plasma density and electrical potential, like a power surge in a terrestrial electrical grid. A component overload. Comet Swan, acting as a capacitor in the solar circuit, absorbs this excess energy. The increased electrical stress pushes it beyond its breakdown voltage. The result is a massive electrical discharge, the outburst on September 26th. The comet flashes brightly as it violently releases this stored energy. A cascade discharge. The comet's discharge does not happen in isolation. It creates a highly conductive plasma channel along the magnetic field lines, connecting it back to the sun. This pathway allows for a much larger, system-wide discharge to occur, drawing energy directly from the sun's own powerful magnetic field.
This solar side of the discharge manifests as the M6.4 solar flare and the accompanying CME. The flare is the arc flash at the power source, triggered by the short circuit created by the comet. This electrical perspective elegantly transforms a series of improbable coincidences into a logical and causally connected sequence of events. The nova, the comet, and the sun are not acting independently. They are all parts of a single, vast circuit, responding to each other in real time through the language of electromagnetism. The upcoming alignment on October 21st therefore represents the moment when the geometry of this circuit becomes optimally configured for a large-scale energy transfer. The alignment of Earth, Sun, and the massive plasma cloud of 3I Atlas, combined with the close proximity of the highly active comet Swan, creates a direct, low-impedance pathway for electrical energy to flow between all four bodies. It is a celestial configuration primed for a powerful discharge, the full consequences of which for solar activity and Earth's own geophysical systems remain the great, pressing unknown. Conclusion: the unfolding mystery. We stand at a remarkable moment in our exploration of the cosmos. We have journeyed from the violent death throes of distant stars to the intricate dance of comets in our own celestial backyard. We have witnessed a chain of events so precisely orchestrated in time and space that it compels us to reconsider our place in a universe that is far more alive, interactive, and connected than we ever imagined. The story we have followed is one of a celestial cascade. It began with an invisible wave of cosmic energy, a prelude from deep space. It manifested in the sudden, brilliant outburst of a comet, a visible sign that the solar system had received the message. It culminated in the furious, targeted response of our sun, a roar of plasma and magnetic fire that confirmed the connection. And now, this narrative builds towards a grand finale, a celestial alignment of profound rarity and potential. On October 21st, the orbital clockwork of our solar system will bring multiple key players into a perfect geometric configuration. An interstellar messenger, a local traveler, our Earth, our Moon, and our Sun will align, all within the most electromagnetically active highway of our solar system. The precedent of the past, the echoes of the Oumuamua event, serves as a solemn reminder that such moments can coincide with the most powerful solar and terrestrial events of our time. The coming weeks will be a period of intense observation and discovery. We will watch for the aftermath of the CME's impact on Comet Swan. We will monitor the Sun for any further signs of an energetic connection to these cometary bodies. And as we approach October 21st, we will watch with a newfound understanding, seeing not just points of light in the sky, but nodes in a vast, interconnected cosmic web. This is more than just an astronomical curiosity. It is a profound opportunity to witness the hidden architecture of our solar system, to see the invisible currents of energy that flow between worlds. It is a story that is still unfolding, a mystery that is still being written across the canvas of the heavens. The universe is speaking, and for the first time, we are beginning to understand its language. A language not of chance, but of connection. The only remaining question is what it will